We're now starting lesson 4. You are improving a factory subsystem. So to remind you, you are an industrial engineer hired by the Cape Cod potato chip factory. You are brought in to help improve one of their subsystems. And then they carry the bags because they're so heavy they can't do more than one at a time. So what do you think might be hurting these factory workers? Their backs. What else?
Their hands.
Their hands, their arms, their knees. So, you are hired, you have been asked to make this subsystem more efficient. What does the word efficient mean?
Efficient means like something that makes it easier.
If you are doing something efficiently, you are putting in the least amount of force or effort to get the same work done. Okay? So we're still moving those potato bags to the loading dock, but we're using less force. Then they want you to look at improving the ergonomics. Make it more comfortable for these workers. So I want you to think about which simple machines reduce the force required to move a load. Eric. Pulley. Do both pulleys? No. The lever, the inclined plane, the wheel and axle, and the double pulley will reduce force. Once you improve your loading dock system, how can you test it to see if it actually makes work easier? How are we going to know we've improved it? Chris?
We'll try the first thing that's like harder that they used to do.
Yeah.
And then take this.
Okay. You're going to get a score sheet that looks like this. And your score sheet is how we're going to judge our designs. I'm going to show you how it works for just by hand. I zero my spring scale. So the force scale, the way I get my force scale is, it takes about 1.5 newtons to pull it here. Then it takes 5 1/4 to lift it up. So 1.5 plus 5 1/4, 6 7/75 newtons. Okay? So you're trying to do it with less newtons than that. Okay? Then ergonomics. Did I have to bend over?
Yes.
So I checked it out. Did I have to pull upward? And then pull downward, I did not do. Look at, you get points taken away for pulling downward. +2, +2. So my total score is 1075. Yes, Tony.
Is having more like points good or bad?
What do you think? So can somebody answer that question? Tony's like, what am I trying to do here? This is what the set score is, 1075. Do I want more or less than 10 and 20 and 75/100? Erica, you want less because I want less effort here and I want less ergonomic scores. So here are the ground rules. You are going to be assigned a simple machine you have to use. You have to use it. So you are using wheel and axle. You are using pulley, and it's either pulley I'll let you use. You get to decide on that. So you have your set simple machine that you have to use. It has to be incorporated into your design. Then you may use another simple machine in your design.
You don't have to use the other one?
I think you would probably want to.
True.
Okay. What is our goal? What is our goal in this Crispin?
To improve our factory subsystem.
So our goal is to improve our factory subsystem. How do we know we've improved it? What 2 requirements are we going to have?
You have to use the machine that you assign. It has to be ergonomic.
So it has to be ergonomic and require less. Okay. So then it says, what materials can you use in your factory design? So list your simple machine that you have to use right there so you can list it. So list the simple machine that you absolutely have to use. What are some things you already know about simple machines? Would you please write that? So we're going to do one more step. We're going to imagine. But you know how I love doing the imagine different. I want you to return back to your regular assigned seats. I'm separating you from your groups because I want you to have different ideas. So what simple machine do you have to use? Write that right there. What other simple machines are you going to do? I want you to draw a picture of an idea. I want your ideas to be original. I don't want you looking at your partners or your group members because I want you to think outside the box. So for example, and it doesn't have to be the perfect drawing. Here's your table. How are you getting it from here to here? Yes. That's
One.
Here's oh, it's right here. Sorry.
I'm just gonna pull the water bottle up the incline plane, hook it up to the pulley, and pull it up to the table.
This is the wheel and axle. It would go over here and they'd take the water bottle and it would take it up, and then you might be able to put it, if it's high enough, put it on the table.
I thought of doing the wheel and axle over to a pulley and then lifting it onto the table from there.
Since I have to use the pulley in my group, my first idea will be to have the load attached to the pulley and lower it down. Then it could be dragged up an incline plane onto the table. And my second idea was to have a wheel and axle cart, and it would go to like the bottom of the table, and there would be strings attached to it, and you could attach it to a pulley, and the single pulley or the double pulley, and lift it up, and then the wheel and axle whole cart could just be placed on the table.
So you are going to share your imagining. Everybody should share their best imagine. All right? So everybody will share their best idea. Then you will come up with one plan. Here is your plan paper. In your plan, you need to draw a diagram of your factory subsystem, label all the parts. You need to list the simple machines you're going to use and list any other materials you will need. For you to start getting the materials and start building them, you need to have this teacher stamped. Someone just said, let's see whose idea is the best. Can I give you a hint? No one's idea is the best. The best one will be when you combine everybody's ideas to make the best one. So look to compromise and combine ideas.
And the double pulley takes less force than the single.
I think we all had the double pulley as one of our tests. My idea, I had that same idea as well.
And then take the wheel and lift up the pulley. And what it is, it's going to have this, and then it's going to go to the lever, which is going to take the arm down and then put it up on the table, hopefully, that it's tall enough. So the wheel and axle with the load on it goes up the table and goes up the incline plane and on the table.
We're going to use two boards, we're going to duct tape them together.
Yeah.
Lesson 4 is the design challenge, so I really want them to go through the engineering design process. I want them to think about themselves as an industrial engineer. So I always start that lesson with, we're industrial engineers, this is what we're going to be doing, and really kind of getting them to go through each step of the engineering design process, as well as I want them to see that it's cyclical, but you also will improve, then you might plan, you might imagine that it doesn't have to go in 100% exact order. I just actually will follow the manual, because what's great about the manual is they have the worksheets that do each step by step. The ask we fill out together because we kind of reflected about it from lesson 3. When they go and do their imagine, I give them the time to do it, and usually I try and end with the imagining, so that way they can have as much time as they want. They may even need to take it and finish it for homework. And I actually break them up from their science groups. I don't let them sit together with their group members because I want them to imagine on their own, so that when they come to their group, each of them will have 2 imagine papers and they share the best one. So then they have 4 hopefully different ideas that they can work into being one idea. I make sure that they understand how they're going to be scored. I think that's really important, looking at the scoring worksheet, knowing that if they pull downward, they actually will lose points, which is what they want. And then when they get into the plan, I make sure that their plans have to be approved by a teacher. So that way, I make sure they're clear plans, they have all the materials listed that they needed, as well as it's thought out, because I don't want them to just start building and not really have a set idea. And I kind of always put to them, they are 5th graders, so I say to them, if I charged you for every single material, would you want to just use all that duct tape, or could you get away with using less?